So, dear students, once again welcome. Here the next problem is there are three cylinders fitted inside the channel. You can see this is the channel, and the statement of the problem is three smooth cylinders, each of radius r and weight w, are placed in a rectangular channel of width 5r as shown in figure. Determine the reactions at all contact surfaces. So here uh, the radius are given. The radius are small r and weight is here w. So you can see this is the channel, this is the channel, and three smooth cylinders are there. So remember, whenever the term smooth is there, smooth cylinders, smooth surfaces, means here friction is not going to be considered. Not going to be considered. Okay. So whatever the contact, like suppose this is sphere and this is the smooth surface. Okay, this is suppose a sphere cylinder, and this is the smooth surface, or you can say floor. ठीक है. So how to draw the FBD? क्या होगा इसका FBD? इसका FBD will be FBD free body diagram will be this one, and it has some weight. So and weight works downwards, and after removing this smooth surface, free body diagram means removing the supports. So after removing the supports, there will be R reaction. It is a vertical line. Okay, and means there will be the contact point. Okay, no friction will be there. That's why the normal, this is the normal reactive force. Okay, to counter the active force that is here W, means weight of the cylinder. So in this way, by drawing the FBD free body diagram of each of the cylinder, we can then get the contact reactions. Okay. So here, what are the contact reactions? So here you can see a contact reaction. Suppose we are giving a name. This is a 1A. This is 1A. This is 2. It is not properly visible. 2A, and this is the 1C. This is 2C. Okay, this is the contact point between the cylinder A, between cylinder A and cylinder B. This is the contact point between cylinder B and C. Okay, so now to draw the FBD of this, what we have to do? To draw FBD of this system. Okay, what we have to do? We have to remove. We have to remove the channel. Okay, and in place of that, in contact points, reactive forces, we need to show. Okay, so this is the it is not so good. Okay, this is B, and this is this one. Okay, this is A and this is C. Okay, so what we are going to show right now, the reactive forces at the contact points. Okay, so here it will be here and here. ये कौन सा हो जाएगा? R1A. This will be R2A, and here it is R2C, here R1C. Okay, and what about here? The reactive force, this one, this one, this one, because A will apply, means some force on B, and B will also apply force on A, means reactive forces. That's why this one and this one. So what will be the name of this reactive force? So suppose a direction for this one, and the direction is towards the B. So this is then R A B. and this is the R B CB, sorry, CB. Okay, and as per the Newton's third law, whether we show R AB or R BA, so in magnitude both will be same. Okay, so these are the reactive forces we have shown. So how many forces are there? Reactive forces are there. This one, this one, this one means second, third, fourth, then fifth is here, sixth is here, and there will be the weight of the cylinders. Okay, so what are the weights? The weight is same for all. W here, W. Okay. So now our purpose is to get the inclination of the inclined reactions. Okay, so you can see here for R1A it is horizontal, R1C horizontal, acting in horizontal directions. Okay, horizontally acting. And similarly R2A and R2C acting vertically, okay, whether vertically here, the actually this will be direction, and direction should be we are showing towards the C. That's why here we need to correct. So both are working vertically upwards. Okay, and R1C, R1A, R1C both are acting in horizontal directions. Okay, either in positive x direction or in negative x direction. So for these are either acting horizontally or vertically, so there is nothing kind of inclination. So our worry is we have to means now the like this one, the name is R A B, so it is inclined force. Also this one R C B, both are inclined reactions, and for that inclination we need to know. So let us find out that. Okay. So let us draw the triangle by adding all the by joining all the centers of the cylinders, as there are three cylinders. Okay, so let us join these, this one, this one, this one. Okay, this is A, C, B, and as radius of each cylinder is R, so that's why this line becomes now 2R, this line also 2R, but length of this in the question you can see length is 5R, length is 5R. So here it is it will be 3R. Okay. Since this triangle is not symmetrical, means all the sides are not of length 2R. Okay, means there is a this one is one side is 3R. That's why the angles will be not same. So what to do to get the angle from the middle of this? We have to draw a line, and this is the perpendicular. Okay, giving some name like O, we're giving them. Okay, so what we have now, then let us so what we have now, this one, this one, this one, this is 2R, this is O, B, A, and it is now 1.5R, and suppose this is theta. So here cos theta will be what? This one, this length 1.5R means base, and the diagonal, this one diagonal, this is 2R, means it is a 3/4. So theta is equal to cos inverse 3/4, and the theta finally we get that is 41.41 degree. Okay. So in this way, the whatever the required angle we now came to know. Okay, so this angle will be theta. Then what about if you draw the FBD, suppose like our cylinder B. Cylinder B. This one. Okay, the weight of this, it is W, and reaction here, reaction here, it is R A B, it is R C B. Okay, so what about angle? This angle, let us this is okay. Okay, so from this what we get actually RB angle. So from the previous relation what we find out, the angle between this, that is theta. So this will be also theta and this will be also theta. Okay, so from the cylinder 1, similarly for the other cylinders, this is the cylinder A. Let us not to put here cylinder A. This is the cylinder A. Okay, and what are the contact surfaces? You can see here. So there is a, it is cylinder 1 A, sorry, cylinder A, and this one and this one. This is R1A, it is R2A, and the weight of the cylinder, that is W, and this one, it is RBA. Okay, and RBA is equal to RAB, as we know. So let us draw a line and extend it, all the line of the actions of the forces. So this is here making 30 degree. This is the 30 degree. And what about the another cylinder? Okay, you can see here. So reaction from, this is the center, and the name is, cylinder name is C, and the reaction coming from the cylinder means the cylinder B. This is the cylinder B. So it is R B C, and here R1C, here R2C, better, here R2C. So what we have to know this angle. Okay, so this angle will be also with the vertical or this one better to means extend it. This actually we are going to extend this one, this angle theta, and this is the B, this is the RCB. Okay, CB. So this angle will be same, so that's why from here to here this angle theta. So in this way we have drawn the FBD of all the cylinders. FBD is now done. Next to satisfy equilibrium conditions. So what are those conditions? So we know summation of fx is equal to 0, summation of fy is equal to 0, because we are talking about only plane. Okay, means two axis, not the third axis. Okay, that's why no summation of f z is equal to 0. This will be this, not, no need to take this. Okay, what about moment? About suppose the any direction, z direction, is it? Shall we apply this? So no, this also no, as the forces are the concurrent forces. Okay, that's why we cannot mean concurrent forces means all the forces are meeting at the one point. Okay, so for this moment what we need to do, suppose moment about z. Okay, so you need to take the distance like r cross product f. So this r we don't get, that's why this summation of moment equilibrium condition we cannot apply. And see, from we have three cylinders. Let us the cylinder B has how many forces? Okay, so W and R AB, R CB. What about cylinder A? So cylinder A has means its own weight, then R1A, then R2A, then and R B A. Okay. What about the cylinder C? So what are the forces? Its own weight, then R B C, then R 1C and R 2C. Okay. So how many forces in cylinder B? Three forces. Three forces. What about in cylinder A? So four forces. Cylinder C. So again four forces. Okay. So can we apply here? Can we apply here the suppose Lami's theorem? Lami's theorem, and here also can we apply? So answer is no, because it is only for three concurrent forces. Okay, so what is the option next? What is the option? What is the option? So our options are summation of fx is equal to 0 and summation of fy is equal to 0. Okay. What about this? Suppose there are three forces only. So we have option. We can apply. We can apply both Lami's theorem and equilibrium conditions. Equilibrium conditions. Okay, so it is your choice as per your convenience. And what is Lami's theorem actually? So Lami's theorem, so like suppose this sorry, we're going to suppose apply the Lami's theorem for cylinder B. So how it is loaded with the forces, means reactive forces and the weight. This is W. And what about this one? What about this one? Okay, so this is R AB and this is R CB. Okay, so what we have to do, this can be converted into like the nature of all the forces are same, means it is coming towards the center. Okay, so this can be written like W and like this is R RCB, this is RAB, and this is the center, as the cylinder name is B. So as per this angle we have to know, this angle we have to know, and this angle we have to know, and angles already we know. Okay, so how to apply that? Like W then divided by this angle. Suppose I am writing here alpha and beta gamma, so W divided by sin alpha is equal to R C B, and opposite of this means sin gamma is equal to, then this one R A B divided by this one angle sin beta. So this we can apply. So it is your choice, either you apply the Lami's theorem or the equilibrium conditions. It is your choice. With this, thank you. So based on this, one can derive the means by applying the equilibrium conditions, the unknowns can be found out. So this is limited to only, this lecture is limited to only to get the to draw the free body diagrams of the cylinders. Okay, thank you.